Here we have an exam assignment from 2016. It is about a company that uses three components, C1, C2 and C3 for its productions. We have weekly demand, we have the average weekly demand and also standard deviation of weekly demand for each component. And we know that the demand for these components are independent from each other. The company uses a periodic review system to control the inventories of these components, and it uses a common reorder period equal to 4 weeks for its inventory system. So these are in weeks, in fact. And as it is stated in the exam assignment text, the lead time is equal to 2 weeks. In the first part of this question, we are asked to calculate the restocking level to ensure that the probability to be out of stock at the time when an incoming shipment arrives is at most 0.01, which is equivalent to having a cycle service level equal to 99%. So that is why you can see this 99% appears here. Okay, let's do the calculations for each component. For the first component, the average demand over Rp plus L, we need to calculate the average and also standard deviation of demand over Rp plus L because it is a periodic review system, so we will use these values in our calculations. So it is equal to Rp plus L multiplied by the average weekly demand. And then for the standard deviation of demand over Rp plus L, we have the square root of Rp plus L multiplied by the standard deviation of weekly demand. Okay, so we can do the same calculations for other components and get the same, find the same measures of same values for each of these components. Next, we need to calculate the safety stock. Consider component C1. Safety stock is equal to the safety factor. So we will use norm Sin to find the Z value corresponding to a cycle service level equal to 99%, and then multiply the safety factor by the standard deviation of demand during Rp plus L. So it will give us the safety stock for component 1, and we know the restocking level is the average demand during Rp plus L plus safety stock. We can do the same calculations for the other components and we will get these results. In the second part of the assignment, it says that instead of using 3 components, we can use a common component. And this common component will be used to satisfy the demands for all of these components. Component 1, 2 and 3. So we are asked to calculate the restocking level for this common component in order to meet a cycle service level equal to 99%. To do so, first we need to calculate the average weekly demand for this common component. The average demand for the common component is the summation of the average demands for these components, for these individual components. So it is 150. And the standard deviation, if you remember the variance if we had a random variable which was the aggregated or the sum of some independent random variables, then the variance of this aggregated random variable would be equal to the sum of the variances of these individual random variables. So if we take the square root, if we put it in the square root, so we'll get the standard deviation. So, and here the demands are independent, the random variables for demands are independent, so we can use this formula. So it is the square root of the variance for the first component plus the variance of the second component plus variance of the third component. Okay, this is the weekly standard deviation of the common component. Let's do the similar calculations to find the demand, average demand over Rp plus L. So it is Rp plus L multiplied by average weekly demand, and then we have a square root of Rp plus L multiplied by the standard deviation of weekly demand. Safety factor is equal to safety stock is equal to safety factor multiplied by sigma Rp plus L, and restocking level is equal to average inventory during Rp plus L plus safety stock. Let's calculate the total safety stock that we keep in the system when the components are not aggregated into one component. So this is the case that we call it a decentralized system. Okay, so the summation is equal to, the sum is equal to summation of these three numbers. As you can see, the safety stock kept in the first case is higher than the safety stock kept when the components are aggregated into one component. Now you can assume a business with thousands of different kinds of items kept in inventory, each requiring some safety stock to protect the system against fluctuations of the demand. And assume that imagine how this aggregation of different components into these common components can reduce the safety stock and consequently the inventory holding costs in the system. This is the subject for the next session, so we'll talk about it more next week.